Today we are going to study examples related to system of linear equation of infinitely many solutions. In last lecture we have studied the examples related to unique solutions. Consider the example of system of linear equation. Now first we write it in matrix form. So its matrix form is, here it is 3 equations and variables are 4. Now from first equation the coefficients are x1 coefficient is 1, x2 coefficient is 2, x3 coefficient is -3, x4 coefficient is 2. Okay. From second row x1 coefficient is 2, x2 5, -8 and 6, and in third 3, 4, -5, 2. Okay, and variables x1, x2, x3, x4 is equal to constant matrix 2, 5, 4. Okay, now consider augmented matrix. A augment B is equal to matrix is 1, 2, -3, 2, 2, 5, -8, 6, 3, 4, -5, 2. Augment constant matrix is 2, 5, 4. Okay. Now here at A11 it is leading 1, it is 1. We have to here made 0 and here 0. So first row operation is in between R2 and R1. So we have to do row operation. Here it is 2 and here it is 1. So multiply R1 by 2 and both are of positive sign. So we subtract it. So first row operation is R2 minus 2R1. And second row operation will be R3 minus 3R1. So we get the next step. So first row will be as it is 1, 2, -3, 2. Second row will be, now consider row operation R2 minus 2R1. Its row operation will be, so R2 is 2 in this 2 and R1 is 1, minus 2 into 1, which is equal to 2 minus 2 is equal to 0. So its first value is 0. Next it is 5 minus 2 into, it is here corresponding value is 2, which is equal to 5 minus 4 is equal to 1. Next it is -8 minus 2 into -3, which is equal to -8 minus plus 6, which is equal to -2. So it will be, here it is 1, here it is -2. Next last value is 6, 2. So you get 6 minus 2 into 2, which gives 6 minus 4 is equal to 2. So it is 2. And last calculation, 5 minus 2 into 2, which is equal to 5 minus 4 is equal to 1. So here it is 1. Here our value is 2 as it is. Next, same for R3 minus 3R1. Okay. So here 3 minus 1 in 3 into 1, which gives 3 minus 3 equal to 0. So first here value is 0. Next 4 minus 3 into 2, which is equal to 4 minus 6, which gives -2. Here it will be -2. Next -5 minus 3 into, it is minus 5 minus 3 into minus 3, which is minus 5 minus minus plus 9, which gives equal to 4. So it is 4. Next, both are 2, which is 2 minus 3 into 2, which is equal to 2 minus 6 is equal to minus 4, which is minus 4. And last, 4 and 2. 4 minus 3 into 2, which is equal to 4 minus 6, which is equal to minus 2. Minus 2. Okay. Now here it is our first leading one. It is here. It is 1 A22 position, so we can take it as leading was. So we have to make 0 below second leading one. To make 0, we need a row operation between R3 and R2. They are with opposite signs, so you consider plus. So we have to multiply it by second row by 2, because here it is 2. Plus 2 minus 2 will be 0. Now first row is 1, 2, minus 3, 2. 2. Okay. Second row will be 0, 1, minus 2, 2, 1. Now third row 0, R3 plus 0. Here row operation is R3 plus 2, R2. So we can write here it as minus 2 plus 2 into 1. Okay. Minus 2 plus 2 is 0. So it is 0. Next, 4 into 4 minus 2 into minus 2, which is equal to 4 minus 4. Sorry, here it is plus. 4 plus 2 into minus 2, 4 minus 4, it is 0. So it is again 0. Minus 4 plus 2 into 2, which is equal to minus 4 plus 4 is again 0. And last here, minus 2 plus 2 into 1 is equal to minus 2 plus 2 is equal to 0. So here our last row is totally 0. So we get leading one in position A11 and A22 only. Here leading one are for column first and second. Okay. So this is our row echelon form. Echelon form. So here C1 column first and columns 2 contain leading 1. And C3 and C4 do not have leading 1. So the system has infinitely many solutions. Therefore, system has infinitely many solutions. So which is of the form? So consider here which for C3 variable, if we consider this matrix, first x1 variable has leading 1, x2 has leading 1, x3 and x4, column 3 is of variable x3 and column is for x4, C4 is for x4. So we here put x3 is equal to yes and x4 is equal to t, where s comma t belongs to R. Okay, which should be a real numbers. So from second row, from this row, we can write R2, row 2 implies. From second row we can write this is of variable x2 minus twice x3 plus twice x4 is equal to 1. Okay. x3 minus twice, sorry, x2 minus 2x3 plus 2x4 is equal to 1. So we get, which implies that here we adjust in this portion only. So we can write it as x2 minus 3, x3 value is yes, plus 2x, yes, it is 2, yes, plus 2t, because x4 we have to put t, is equal to 1. Therefore x2 is equal to, now we shift it toward left, 1 plus 2s minus 2t. Okay, this is value of x2. Now from first row of above matrix, now from first row we can write here it as x1, its first coefficient is 1, so we write here x1. Next coefficient is 2, so we write it as plus twice x2. Next coefficient is minus 3, so we write here minus 3x3. And last coefficient is plus 2 x4, and is equal to, there it is 2. Okay, so here substituting the values of x2, x3 and x4, we get the value of x1. So x1 plus twice x2 is 1 plus 2s minus 2t minus 3 into x3 value is above, yes, and x4 value is t, twice t, is equal to 2. So we get x1 plus 2 ones are 2 plus 4s minus 4t minus 3s plus 2t is equal to 2. So shift all these values to left, we get 2 minus, okay, 2 shifts all these values to the right side, minus 2 minus 4s plus 4t plus 3s minus 2t. Now simplify, which is possible. Plus 2 and minus 2 will be 0. Now here minus 4s plus 3s, which is minus s. 4t minus 2t is plus twice t. Okay, so we get x1 is equal to minus s plus 2t. x2 is 1 plus 2s minus 2t. Okay, and x3 is s and x4 is t. x3 and x4. So here the solution set is, s is equal to, solution set is a matrix. First x1 value is minus s plus 2t. Second value is x2. x2 is here x2 is 1 plus 2s minus 2t. 1 plus 2s minus 2t. x3 is s and x4 is t, where s comma t belongs to R. Okay, which is our required solution. Okay, these are two examples for your homework work. Solve by Gauss elimination method. Okay, whose answers are, its answer is x1 is equal to x is equal to minus 2t, y is equal to minus t, and z is equal to t. Okay, here only one column has no leading one, so it is two variable. One variable do not have a leading one, and this example has a solution. x1 is equal to minus 3 upon 7t, x2 is equal to minus 4 upon 7t, and x3 is equal to t. Okay, please solve these examples. Okay, now we see about system of linear equation which do not have a solution. So example is this. Now we first write in matrix form. Matrix form is first, matrix is first, from first equation it will be 1 5 4 minus 13. Okay, coefficients only 3 minus 1 2 5. From third row 2 2 3 minus 4. Okay, variables are x, y, z and w, is equal to constants are 3 2 1. Okay, Now consider A argument B, which is equal to matrix 1 5 4 minus 13, 3 minus 1 2 5, 2 2 3 minus 4, and 3 2 1. Okay, which is equal to, now here A11 is 1, so it is our leading one, first leading one. Now subtract R2 and R1 row operations. Here both are positive, so R2 minus 3R1 and R3 minus 2R1. Okay, here it is 2, so we write here R3 minus 2R1. So we get first row as it is 1 5 4 minus 13 3. In Gauss elimination method, first row is always remains same. Okay, first leading one's row. Okay, now here R2 minus 3 R1 row operations gives 3 minus, okay, here it is 3 minus 3 into 1, which is 3 minus 3 equal to 0, so it is 0. Next, minus 1 minus 3 into 5, which gives minus 1 minus 15 is equal to minus 16. Okay, minus 16. Next, it is 2 minus 3 into 4, which is 2 minus 12, which is minus 10. 3 4s are 12. Okay, minus 10. Next, it is 5 and minus of minus 13, minus 3 into minus 13, which is equal to 5 plus 3 into 13 is 39, which gives 44. Okay, it is 44. And last, it is 2 minus 3 into 3. 2 minus 3 into 3 is 2 minus 3 into 3. 2 minus 9 is equal to minus 7, which will give minus 7. Okay, now third row. For third row, we have row operations R3 minus 2R1. R3 minus 2R1. So first row operation will be 2 and 1. 2 minus 2 into 1 is equal to 2 minus 2 is equal to 0. Okay, this is our rough calculation. It is not used in examination. It is for your understanding purpose only. Okay, do not write this in exam. So here first is 0. Next, 2 minus 5 and 2 into 5. 2 minus 2 into 5, which gives 2 minus 10, which is equal to minus 8. So it is minus 8. Next, it is 3 minus 2 into 4, which gives 3 minus 8, which is equal to minus 5, which gives minus 5. And last, it is minus 4. Minus 4 into 2 into its corresponding value is minus 13. Minus 13, which gives minus 4 minus minus plus 26, which is equal to minus 22. Okay, which is minus 22. Sorry, plus 22. Here it is plus 22. And last value is 1 minus 2 into 3, which is 1 minus 6. 1 minus 6, which is minus 5. Okay, now here we get first leading one. Now we have to, here it is non-zero value, so we can make this as a 1 by multiplying 1 upon 16, minus 1 upon 16 to row second. So we get minus 1 upon 16 multiplied by row second. So we have first row as it is 1 5 4 minus 13 3. Second row is 0. Here minus 16 upon 16 is 1. Next value is minus 10 upon 16 is 10 upon 16. Okay, next is 44 upon 16, which will become negative minus 44 upon 16, because we are multiplying by minus 1 upon 16, and last value is 7 upon 16, and last column is 0, minus 8, minus 5, 22, minus 5. Okay, now here is our leading one. We have to make 0 in the position A32. So we have a row operation R3 and in between R2 here plus 8R2. Okay, so it will be minus 8 plus 8 0. So we calculate here R3 plus 8R2 row operation. So first we write here as it is 1, 5, 4, minus 13, 3, 0, 1, 10 upon 16, minus 44 upon 16, 7 upon 16, 0. Here it is minus 8 plus 8 into 1. Okay, minus 8 and here 8 into 1, which is minus 8 plus 8 equal to 0. So this is our term 0. Next it is minus 5 into plus 8 into minus 5 plus 10 upon 16, 8 into 10 upon 16. Okay, so we can write 8 ones are 8, 8 twos are 16. Okay, 2 ones are and 2 fives are. So we get here minus 5 plus 5 again equal to 0. So next is also 0. Next 22 plus 8 into minus 44 upon 16, minus 44 upon 16, which gives 8 ones are 8 twos are, 2 ones are and 2 22s are, which gives 22 minus 22, because here sign is our negative, plus minus it will be minus, so it is 0. So here it is 0, and last calculation is minus 5 plus 8 into 7 upon 16, 8 into 7 upon 16. So 8 ones are 8 twos are, minus 5 plus 7 upon 2. So make LCM here. So it become minus 5 into 2 is minus 10 plus 7 upon 2, which gives minus 3 upon 2. So here we get minus 3 upon 2. Okay, so here it is our leading one, here it is our leading one. But in this example, if we see left side of coefficient matrix of this argument matrix, here all the terms are 0, and in right side it is minus 3 by 2. If we write from last row, which is R3, which gives 0x plus 0y plus 0z plus 0w is equal to minus 3 by 2, which is 0 is equal to minus 3 by 2, which is not possible, okay, which is contradiction. Okay, that is system has no solution. Okay, that is system is inconsistent. Okay, we have to see this matrix, augmented matrix. If it is all 0, if it will be also 0, then we can solve it. But here left side is 0 and right side is not equal to 0. So this type of example gives us a contradiction, that is which this system will not have a solution. Okay, so in this lecture we have studied system of linear equation in which Gauss elimination having infinitely many solution and no solution. Okay, now homework for no solution. So this is your homework. Solve x1 minus 2x2 plus x3 minus 4x4 is equal to 1, x1 plus 3x2 plus 7x3 plus 2x4 is equal to 2, x1 minus 12x2 minus 11x3 minus 16x4 is equal to 5. Okay, so we stop here for today. Okay, thank you.